everyone, I'm going to tell you a bit more about my project on the Campine Plateau. But first, something about my fascination snowboarding. To experience this sport in a fun way, some factors are crucial. For instance, the continuous presence of snow, long steep slopes, easy accessibility, and a large height difference. But as you know, Belgium doesn't have the ideal landscape for snowboarding, so I've divided it into 3 different activities that approach the qualities of snowboarding: wakeboarding, sandboarding, and water sliding. While wakeboarding is done on the water, the other 2 also require a slope. For this design brief, we have to deal with the problems that water brings to us. The problems that arise are due to far too little infiltration and too fast drainage. In my analyzed area, the factors of runoff, pavement, and vegetation are strongly present, which have a great impact. A first factor that is strongly present is the runoff of water through the landscape. There are several streams that drain the water from the higher level to the meuse as quickly as possible, so the water has no time to infiltrate on site. The second factor is pavement. At just about the lowest point in the landscape, there is a string of villages along the Meuse River. During heavy rainfall, the water cannot pass through the surface. It will then find its way to the Meuse as quickly as possible, so it cannot infiltrate. A third factor is the vegetation type. If we compare a deciduous forest with a dark coniferous forest, we see that 28% more water evaporates in a dark coniferous forest. As a result, there will also be 28% less water infiltration. Unfortunately, we see that there are much more coniferous trees present. The previous factors have a negative impact on the water problem, resulting in droughts and floods. Drought in places with a lot of nature and flooding in the inhabited areas causing disturbance. We get into a vicious circle, so the problem just keeps on growing. In the places in the landscape where we have a lot of infiltration potential, very little infiltration is done, and where water should be retained, a lot of drainage is done, which lowers the groundwater table. This will eliminate several water systems, such as upstream and downstream valley systems. Beside the vegetation, the pavement, and the water courses, there are other layers that have an effect on the water. For example, the soil types, the relief or slope gradation, and the land use determine how much water would flow away over the surface and we could capture afterwards. We call this the potential runoff coefficient. Then I start looking for the perfect location to solve the water problem. For this purpose, the style edge seems to me the best location to solve lower level problems. I would like to transform the current system into a new system that would hold back the water and reduce droughts and floods. But the question is now, how can we transform the style edge to help solving the water problem, so that we infiltrate more water and drain less water from the landscape, and this also in function of the fascination of snowboarding. I created a strategy to address the style edge. The first step is to transform the vegetation. The current abundant conifers will give way to a more diverse vegetation along the style edge. Some places on the slope will have a sandy surface according to my fascination and infiltration capacities. The second step is the ground displacement. At the bottom of the style edge, at the 65-meter height line, soil is dug out and used to raise the style edge, giving an even greater height difference for the benefit of my fascination. Also in the valleys, soil is dug out in several places to raise the indented style edge. Because of the excavations of the previous step, we come to the third step where several infiltration basins are created. The water can be held back on the plateau by the raised slope, at the bottom of the valleys where the soil was dug out, and along the entire edge where the excavation was done. By forming those infiltration basins, a lot of rainwater can be collected and infiltrated into the soil instead of flowing away from the landscape. For example, 80,000 million liters of water falls from the sky on the plateau, and 12,000 million liters in the valleys and on a steep edge that can be retained. So the water is held back 3 times. The first buffer is on the plateau. In this zone, it is ideal for water to infiltrate. The second buffer is in the valley, where the water must be retained. And the third buffer is located along the entire style edge. By doing this, the groundwater table will be able to rise back up. In the fourth step, where I'm going to implement my fascination, I'm investigating where I can integrate the different activities related to snowboarding. Each activity or sport needs different requirements. For example, sandboarding and water sliding will take place at specific locations on the slope or the style edge, and wakeboarding has other requirements. Because of the excavation and the creation of a water route, it is possible to implement a wakeboarding route of about 20 kilometers from Stockholm to Lanaken. Equal to this route, a cableway is connecting the landscape. These new structures are parallel to the current structures of the Meuse and a string of Meuse villages. For the other activities, I will be looking for locations where a transformation can take place and an ideal environment can be created for sandboarding, water sliding, and wakeboarding. At these locations, the conifer can be transformed. The soil consists of arenosol that are suitable for sandboarding. The locations with the steepest slopes are also selected. Some infrastructure will be needed to finance this major intervention and thus make it feasible. From this follows a design where all these elements come together. A design that connects the landscape, a design that connects different facilities, and finally a design that connects the different sports related to snowboarding.